All right, we are now at the last section of chapter 6, taking a look at 6.6 inequalities into triangles. And so, right here, we're going to be comparing two triangles, and we could actually figure out um, which triangle may have a larger side or which two triangles may have larger angles uh, with the help of some theorems. So, let's take a look at our first theorem here, 6.12, which is the hinge theorem. And so it states if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. What does all that mean? Look, you need two congruent triangles, okay, first off. So if I take a look at these two triangles right here, I know that they're congruent because they have several markings. We have Vx is congruent to RT. We have VW is congruent to RS. And then what they're saying is we want to look at the included angle, the 88 angle V and the 35 angle R. So based off of these included angles, what we can say is since this angle right here, 88, is opposite of our side VX, or sorry, XW, then that tells us that XW is going to be greater than side ST, okay? Because it's opposite of the 88, while ST is opposite of the 35 degrees. So there is your hinge theorem. You need two congruent triangles or two sides of one. All right, so the triangles are not absolutely congruent, but two sides of one triangle are congruent to two sides of the other, okay? So we can't necessarily say that the two triangles are congruent, or else then the angles would also be congruent. All right, so we have the converse to the hinge theorem. And I put right here, the sides are given. Okay, so that's what we're going to be looking at when we make our comparison here. So it says if two sides of one triangle are congruent to two sides of the other triangle, and the third side of the first is longer than the third side of the second, then the included angle of the first is larger than the included angle of the second. So once again, we break things down. We have two sides of each triangle to be congruent. CB right here is congruent to FE. And then we have AC is congruent to DF. And so I'm looking now at the opposite, looking at the third side. And then I'm looking at the angle opposite of the third side. And so because this AB, which is 12, is larger than DE, which is 9, we can safely say that angle C is larger than angle F. And that is the converse to the hinge theorem. So with the hinge theorem, the angles are given and we find what a side is longer. With the converse to the hinge theorem, the sides are given and then we're figuring out which angles are larger. Pretty simple concept here. So that brings us to our extra practice. Let's take a look and apply what we just learned. It also says to explain your reasoning, so make sure that when you guys do your homework, to also give a reason on justifying your answer. So right here, we have two sides and an included angle. And I'm looking at, so let's take a look at the angles. I got angle A is 35 and angle D is 45. So it looks like right here, angle D is the larger angle. So the side opposite of that, which is DF, is greater than BC. So we can go ahead and put BC is less than EF. What is the reason? Remember, when the sides are given and the included angle, we can go ahead and put hinge theorem. All right, let's take a look at number 2. I'm taking a look. We got two sides congruent of each triangle. And so let's take a look. Angle A is 95, angle D is 20. So we should be able to say that BC is greater than EF. Okay, so and then the reason for that we have is the hinge theorem once again. All right, let's take a look at number 3. We have, um, once again, two congruent sides of each triangle, and then we have right here 90 and 90. Well, the angle is the same. The two triangles have two congruent sides. We can go ahead and say that these two are equal in length. BC is equal to EF. All right. That once again, we have ourselves our hinge theorem. We'll move along to number 4. Measure of angle A is something compared to measure of angle D. So let's see right here. If I'm looking at A, I'm looking at D, and I see right here these two sides are congruent. All three sides happen to be congruent of each triangle. So that right there should tell me, let's see, that everything, angle A is equal to measure of angle D, because no sides are greater than the other. So right here, we can go ahead and now, which theorem can we use? Think about, remember, in order for us to use the hinge theorem, we have to have two sides and an included angle. And then right here, we could also say for the converse, remember, we need angles and sides, or we need angles. And so we have none of that. So we think about what we learned earlier on in the school year. These two triangles are congruent, and we have side, side, side. Or if the sides are all congruent, then we have two congruent triangles. We also have the angles to be congruent, because after that, we could say that all the different parts are congruent. And then don't forget about CPCTC. So number 4 is a little tricky right there as far as the explanation of it. For number 5, let's take a look. Angle A, angle D. We have two sides of each triangle congruent. Looks like this is the larger side, opposite of D. So that should tell me that angle D, or measure of angle A, is less than the measure of angle D. And this one right here, we've got the converse to the hinge theorem. Number 6, let's take a look right here. I've got two isosceles triangles. I have 9 is the larger side, opposite of angle A. So measure of angle A is greater than the measure of angle D. We have two congruent sides and one the third side. So this right here is the converse to the hinge theorem as well. Let's move right along to number 7. We've got right here A and B. So let's see, do we have two congruent sides? We should, and we do, because think about this. Just like in our theorems before with these triangles, we have two triangles and they share a common side. So therefore, we do have two congruent triangles here, or at least two sides that are congruent in each triangle. So now let's take a look at the angles. Right here, this angle is the larger one, and that's opposite of side AB. So we can go ahead and say that AB is greater than AC, which is opposite of this 135. Reason, we have our hinge theorem. Remember, two congruent sides and then the included angle. Right here, number 8. Take a look at the diagram, look at some of the markings they have. We have in each triangle, we've got two congruent sides. And look right here, we've got these angles, and hopefully you remember the relationship between the two, they're vertical angles. So since they're vertical, they're going to be equal to each other. And so BA or AB right here will be equal to CD. And for this one, since they didn't give us an actual angle measurement for the included angle, we could say that, hey, we got two congruent triangles right here, sides, uh, all sides, all angles are corresponding sides and angles are congruent. So we could say we got side angle side right here, and then we got CPCTC. And then finally for number 9, we got, let's see, we've got two triangles. They have two congruent sides because they both share this common side right here. And so I'm looking at angle 1, opposite of that is 19. That's bigger than the 17, which is opposite of angle 2. So I could say that angle 1 is greater than angle 2. And we have ourselves the converse to the hinge theorem. All right. Let's go on to the next page. So to think that you are done with proofs, you are not. We have it one more time right here in chapter 6, and you're going to write a proof. And so let's do that. Remember, step 1, you're going to put down what is given, and hopefully you had remembered that or was going to say that yourself. So let's put all that stuff down. All right, so let's see. We do have two triangles that happen to be congruent or have two congruent sides. So we got x, y, congruent to y, z. And then we also have this the second side right here that is shared by both triangles. So we're focusing right here on angle W, Y, X. So we're focusing on this angle right here, and I'll highlight that in green. And then we're also focusing on W, Y, Z. So I'll go ahead and let's highlight the second angle right here in blue. So we're trying to figure out, well, how can we prove that that W, Y, X is greater than W, Y, Z? So what else do we know here? What else can be can we figure out? Let's also remember right here that number 2, we have WY is congruent to WY, reflexive property. Because remember, if we want to be able to prove or justify whether we use the hinge theorem or the converse to the hinge theorem, we have to have either two angles or two congruent sides and included angle. So let's see what we have here. The other piece of information, remember, they tell us is that WX right here is bigger. So this is the big side opposite of this angle. This right here is a smaller one. All right. So thinking about that, that will help us understand and justify that WYX is larger than WYZ. So I can go ahead and say now, with the help of the reflexive property, because that gave us two sides, and then we actually have the third side because they gave it to us in the description right here, that the measure of WYX is greater than the measure of angle WYZ. And right here, because it's two sides, and then they give us a description of the third, we can go ahead and put the converse of the hinge theorem, or to the hinge theorem. All right, so we put it all together. So we had to justify using the converse to the hinge theorem. And therefore, that second statement right there is absolutely important to add. All right, let's take a look at number 11. We have right here, let's put down what's given. We have AD is congruent to BC, and then we have measure of angle DAC is greater than the measure of angle ACB. So one right there, that is given. So let's see how this all looks. Um, Remember, in order for us to do any of these theorems, we have to have either two sides that are congruent, and it looks like we can do that if we take a look at side AC. They're both shared in each triangle. So let's go ahead. We have to make sure that we do have two congruent sides. AC is congruent to AC, and then once again, we have our reflexive property. And so we'll add that right there. Knowing that angle DAC, okay, so we're taking a look right here at this angle DAC, and this angle DAC is supposed to be larger than ACB. So let's take a look right here. This is supposed to be larger. I'll just put large right there, comparing that to angle ACB, which is small. So what that tells me right here is that this side, it's opposite of angle A right there, or DAC, which is DC. We can go ahead and justify that DC is greater than AB because of the hinge theorem. Just like that. All right, so we have our two proofs done right here. And let's take a look at number 12 and 13. All right, so it says loop a rubber band around the blade ends of a pair of scissors and describe what happens to the rubber band as you open the scissors. And how does that relate to the hinge theorem? So I've got this scissors right here. I don't have a rubber band, unfortunately, but think, how does the hinge theorem apply right here? Okay, think about, how could I make two triangles? Okay, they're saying that loop a rubber band around the edge. So like the end right here and the end over here. And so think about it. What would happen to the rubber band that's right here as I open the scissor and close the scissor? Okay, that's essentially what they're saying. What's supposed to happen to the rubber band, or that third side right here as I open the blade and close the blade? And if you put it all together, if I open the scissors, then what happens to that third side? So right here, if I open it up, what happens to this third side? Right? What happens to the length of the third side as I open it up? And hopefully you figured out that we could say the rubber band is the third side, and I guess as the scissors open up, the band slash third side gets longer. Just like that. Pretty pretty simple concept now that we have a reason for it, right? And then lastly, let's take a look at number 13. Now, on a problem like this, definitely want to make sure that we have like a diagram. I think that would be the best way to go about doing this. And so let's see why. It says starting from a point 10 miles north of Crow Valley, a crow flies northeast for 5 miles. So let's say right here, go ahead, we'll put a point and we'll say that's Crow Valley. And a crow flies north, starting point north 10 miles. So let's say here goes the crow, and it's going up right here. We'll say 10 miles. And then it goes northeast for 5. Let's make this a little bit longer. And so it goes northeast for 5, so that's going up to the top and to the right. And so we could say it went northeast 5. And then it says right here, next up, another crow starting point goes south for 10 miles. So here we go, it goes south for 10 miles, but then it flies due west for 5. Okay, so then it says which crow flew further. So let's think about right here. When we talk about further, looks like we want to have 2 points or the straightest to determine the distance. 2 points straight line. So we'll go ahead and say that these right here are the sides that we're going to be dealing with that I put in green for each triangle. I've got two sides that are congruent in each triangle, and so now let's figure out how we could find the third side. Well, if this, let's look at the triangle that's in red. If it went directly west, then that means it took a hard turn, and we'll go ahead and say it took a 90-degree turn. If you look at this one that went in blue, that went northeast, well, that triangle right there, hopefully you could determine that is obtuse, right? That's a bigger triangle, or at least a bigger angle. So putting the hinge theorem together, what do we know? What do we know? Well, what I do know is that an obtuse angle is bigger than 90 degrees. So what that should tell me is that this this crow right here, the crow that flew north flew further than the crow that flew south. And let's think about the reason why. I've got two congruent sides, and then I've got the included angle. So that right there would be, so we say the crow that flew north flew further than the crow that flew south. And then let's see, we could say it's the hinge theorem, right? So I'm just by way of the hinge theorem. There we go. Sorry about that. My tablet went a little wacky. because of the hinge theorem. All right. So now we've finished chapter 6 right here. And coming up soon, we'll have our tests. So hopefully, make sure you go back, review the chapter, and we'll go over anything you need when we have our review.